Okay, on this example, it says that a recent national report states the marital status distribution of the male population age 18 or older is as follows. Never married, 31% of all men. This is the male population 18 and over. 31% of all adult men never married, 56.6% are married currently, 2.1% are widowed, 10.3% are divorced. The table below shows the results of a random sample of 1876 adult men from California. Test the claim that the distribution from California is the same as the distribution for the whole nation at the alpha 0.01 significance level. So is the distribution the same for California as for the whole nation? That's the test we're doing here. So this is a goodness of fit test. How do we know? First off, how do I know that this is a goodness of fit test? Well, if you look at the notes, let me come up here to the notes with you. This is way up here. So here is the Unit 4 notes. Unit 4 notes. Goodness of fit, as you see down here, it says category percentages are listed. Category percentages are listed. So we are trying to see so that's what we have. We have category percentages, right? It said married, not married, divorced, widowed. So there it is, category percentages. That's goodness of fit, category percentages. So I come on down and go, oh, okay, this is a goodness of fit test, which we answered right there. Because why? Because we've got these different category percentages. So it's a goodness of fit test. How well does this fit with this? Right? We only took one sample. That's the way you can tell it's a goodness of fit, and it's not a homogeneity. That's the other kind of test we have that's pretty similar. Homogeneity is seeing if two samples are really the same. See, this right here is our sample. This is not a sample. This is percentages listed for the whole nation. It's not from a sample. So we don't have two samples here. We just have one sample. So this is this is our one sample. This is our one sample. We sampled a bunch of California men, and we're seeing if they're the kind of the same as the whole nation. So that's goodness of it. Do they fit? So basically, the question is, do California men fit? Do California men fit with men in the whole U.S.? As far as, their marital status, for the whole United States, this is for the whole United States, right? This is, a national report. Never married, 31%, married, 56.6, widowed, 2.1, divorced, 10.3. So, so we can see the decimal there. Anyway, and then this right here is California men. So do California men fit with men in the whole U.S.? So we took one sample. This is the one sample to see if California men fit with the whole U.S. That's goodness of fit. That's not homogeneity. Homogeneity is when you take two different samples. Two different samples. That's different. Okay. So, so then the question is, so for goodness of fit, let's go back to the notes. What do we do for HOH1? So once we know it's goodness of fit, one sample, see if it fits. HO is observed and expected data fit well. H1 observed and expected data do not fit well. Fit well, do not fit well. And then copy and paste the observed data values. Copy and paste observed data values. Okay. So HO, they fit. So HO is going to be, they same as nationally, because that means it fits. California fits with the nation. They're the same. That's what it says right here. California is the same as the nation. They fit. And so basically fit or same as men in the whole US. And down here, it's not the same. Right? Not the same, be this option. Not the same. Not the same. So California not the same as the US. And then this one will be California min the same as the US. So California min not the same as the US or the same as the US. That's what HO and H1 says. That's in the notes. Okay. So now we need to go to the calculators. Let's go to the calculator. Let me go back here. So it's going to be, I believe, I don't know. I'm not exactly sure which one it is. Let's go there. Is it 21? Yeah, 21, goodness of fit. There it is. 21, goodness of fit. And so first thing I mentioned, you got observed and expected. So we got to take the observed values. Let me go grab those. Where is it? There? Oh, no, that's not it. And that's it. These are the observed. This is what was observed for the Cali min, the California min. We copy those values, and we're going to paste those values into this chart to test out the California min. Whoops, I went to the wrong thing. Let's go to the online calculator and paste in those values. There's observed, got to put commas between them. We don't have to fix the spacing, but we got to stick commas. So there we go. Then we'll go to the expected. Now, the expected are not going to be so easy. To get the expected values, we have to come in here and let me show you in the notes. Wait, it's right up here. I'm losing myself in the places. Up here, the notes. So it says for the expected values, we calculate the expected values in one of these two ways. We're going to do number two because we have category percentages. What are you going to do? For each different value is each category percentage as a decimal times the total of all values. And then you list them with commas in between them. So each category percentage is a decimal times the total of all values. So, okay. So I'm going to come back here and I'm going to do that. So I'm going to take each category percentage. In fact, let me just write them in here. So never married. This is supposed to be, well, I'll just do 0.31 because it's, yeah, this is 0.30 here. I'll run right here. Never married is 31%. Married is 56.6%. Widowed is 2.1%. Divorced is 10.3%. So we're going to take each of those and move the decimal back to us and multiply by the total number, which was right here, 1876. So there's 1876 men in this California study. So we're going to multiply. The next one's going to be 0.566 times 1876. Do you see how I come up with that? It's because the decimal goes back two places, right? 1, 2, right? It was right here, 1, 2. It was right here, 1, 2, right? You think where it's always there at the end. And then so 2 point, what? It's going to be 0.021. How did I get that? Well, because it was originally right here between the 2 and the 1, 1, 2. So notice it always goes back 2. So a lot of students get confused and think, oh, Ms. Tarrant, sometimes it's 2 back. Now it's 3. These are 3. No. Don't think about the final result. Think about it's not going to end up 2 back every time. No, that's not the rule. The rule is it's going to move 2 more back from where it started. So it might end up 10 back. If it started 8 back, it's going to move 2 more and be 10 back. You tracking with me? So if it starts right here between the 2 and the 1, 2 back will be, 0.021. If it starts right here between the 2 sixes, 2 back will be 0.566. If it's not even showing, then it's here, 2 back is 0.31. That makes sense? It's always 2 more back. And then 10.3 is going to be 0.103 times 1876. Get all these values because, again, it started here, 2 back. All right, let's get ourselves some happy numbers. They'll be happy. So what are those numbers? So just use your calculator, multiply. I'm just going to write down the results in the interest of time. So I'm getting 581.56. I'm getting 1061.816. I'm getting 39.396. I'm getting 193.228. So those are the 4 numbers. And those are what's going to go in the expected. This is what we expected these four numbers are what we expect if California men really do fit with United States men, right? Because for the United States men, 31% of all men in the United States have never been married. So we would expect 31% of times the 1876 California men in our study to never be married as well, if California men are really the same as men in the whole United States, which would be 581 men would never be married, and et cetera for the rest of the category. So we're saying this is what we would expect to happen if California men are really the same as men in the whole nation, and we surveyed 1876 California men. If the same percentages held for California men, multiply those together, you'd get this number of men in the various categories for California men. And so we're going to put that in for expected. Let's go to the calculator and do that. Put commas between them. So here we go. So 581.56, comma. Oh, that's not a comma. Where's the comma? There it is. Comma. And then 1061.816, comma. And 39.396, comma. And 193.228. There we go. So, and then say calculate. So the calculator is basically telling us now how well the observed values fit with the expected values, right? What we observe, what we expect. There's the chi-squared number, the x-squared is called chi-squared, and the p-value 0.01149. Let's go back, see if that's what we got. Yes, indeed. There's the p-value. There's the chi-square number. The test statistic is called chi-square. This is the p-value. All right. So now let's see what this means. Here's our p-value. So the p-value 0.0115. 0.115. How does that fit with alpha? What's alpha on this one? Alpha is 0.1. Alpha right here. That's p-value. Is 0.1. Who's bigger? Well, if you're not sure, line them up right here. I'll bring them up here. 0.0115 and 0.01. When I say line them up, I mean line up the decimal, right? Decimal right over decimal. So I line those up and then just fill in zeros where the blanks are. So which one of those numbers is bigger? 115 is bigger than 100. So this p-value is greater, isn't it? See that? 115 is bigger than 100. So again, if you're not sure, line up the decimals and fill in zeros wherever the blanks are. 115 is bigger than 100. So we go, oh, okay, so the p-value is greater. So you remember the saying now, if the p is low, the HO, the null must go, meaning go away. If the p is low, the null must go. Is our p-value low? No, this one is not low. Right, our p-value is greater. It's not low. So the p-value is not low. Let's go back and fill in. If the p-value is not low, the HO must not go away. HO must not go. So in our case, HO is not going to go away, meaning we're going to fail to reject. It's not going to go away. We're not going to reject it. We're going to keep HO. Okay. And then what does that mean? Remember, you always want to write next to HO weak evidence. And by H1, strong evidence every time. HO is weak and H1 strong evidence. Okay. So we are going to keep HO. So you come on up and you just take exactly what HO is saying, which is what? Weak evidence. California men, the same as US men. So weak evidence, which means California men, the same as US men. That's what it says. And so let's see that right here. Failed to reject the null, failed to reject HO. And our final conclusion, so it's weak evidence, weak. So that's, it's not sufficient. Sufficient is strong. Get rid of those, right? It's insufficient. Sufficient means enough. Insufficient means not enough, right? So if you have a enough, you studied enough to do well on the test, you studied sufficiently. If you didn't study enough, you studied insufficient. Insufficient is not enough. If you write a check for $1 million, you don't have $1 million in your bank account, the bank will say you have insufficient funds, not enough funds. All right, so weak is insufficient. So which one of those is right? Now this is where it gets tricky. Watch this carefully. California men are the same, right? That's where we're clear. California men are the same as men in the U.S. So insufficient evidence to conclude same. I think there it is, same. Insufficient, same. No, watch out. The real answer is right here, as you can see, not the same. Insufficient, not the same. Why? Why is, you think, no, why? It's same. Why are you choosing not the same, Heron? Because that's what the statement, the statement says there was insufficient evidence. Think about what that means for a second. This is where you got to think logically about words. That means not enough. Insufficient means not enough. Not enough evidence to conclude not the same. So we instead conclude same. California men, same as US men. Are you getting it? I know this is a tricky statement. The right answer is to say there was not enough evidence to say not the same. That's what this says. Insufficient evidence to conclude blah, 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 that they're not, that there was not enough evidence to conclude that California men are not the same. There was not enough evidence to conclude they're not the same. So that means we concluded they are the same, which is what we did, in fact, conclude. California men are the same. It's a double negative. It's like if I said, I did not drop that ball. So that means I held the ball, right? If I did not drop the ball, then I kept the ball. The not cancels the drop, right? It's two negative statements make a positive. That's what this is saying. That's our conclusion, right? Because we know it's insufficient evidence. So you got to read. So whenever it's insufficient, you got to read these carefully. There was insufficient evidence to conclude they were not the same. So we concluded they are the same. And that's what we conclude. They're the same. Now, again, let me go over this one more time. How do we know this? Well, we have our saying. If the P is low, the null must go. If the P is not low, the null must not go. Our P value is greater. P value is greater. It's not low. So if P is not low, the HO must not go away, meaning we're not rejecting the null, we're keeping the null. So I want to back up and say, okay, we're keeping the null. What's the null say? Weak evidence always. And it says California men are the same. So we're saying there's weak evidence and California men really are the same as men in the United States. So how do you say that? There's weak evidence. There was not enough evidence to conclude they're not the same. Oh, so we conclude they are the same. Right. This is saying the same thing. There was not enough evidence to conclude not the same. That's the same thing as saying we concluded they're the same. Because there was not enough to say they're not the same. All right. I've said that a million times. I hope that makes sense. And so there we go. I know it's tricky.